another important question. We need to show this left hand side to be equal to this right hand side. So for that, I know that a plus iota b is your complex number. So let me take this a plus iota b to be the complex number, and let me take this complex number in the polar format, that is r e the power iota theta, right? Okay, further I can write this as, okay, this is a plus iota b. r e the power iota theta can be written as, by using the Euler's formula, it is r into cos of theta plus iota sine of theta. Now because we need the value of r and theta, so for that let's compare the real and imaginary parts. So from here the real part is a, and from the right hand side the real part is r cos of theta. And now comparing the imaginary part, and we have here r sine of theta. If I square both the sides and then add these equations, I will be getting a square plus b square equal to r square cos square theta plus r square sine square theta. Taking r square common, I get cos square theta plus sine square theta, that is equal to 1. So I'm getting r square over here. That is, I get r square to be equal to a square plus b square, or r is equal to the square root of a square plus b square. So here I get the value of r to be square root of a square plus b square. Now I need to get the value for theta. Let me divide these two equations. So I'm dividing b divided by a equal to, I'm having b to be r sine theta, right? So this is r sine of theta divided by r cos of theta. And this r is cancelled out with this r, and we get b divided by a to be equal to tan of theta. And from here we get the value of theta to be tan inverse b divided by a. Very fine. So we have got the values of r and theta in terms of a and b. And now we need to put these values in this equation marked as 1, so that I can get the value of a plus iota b. To put this value over here, we need to evaluate the left hand side. But before that, let me write the complete left hand side first. So this is a plus iota b the power m by n plus a minus iota b the power m by n. Now a plus iota b is this, that is r into cos of theta plus iota sine of theta, and whole power m by n. Similarly, we can write the value of a minus iota b. You just need to replace iota with negative iota. So here I am having cos of theta plus iota sine theta. I need to write minus iota sine theta. That's it. The power m by n. So this becomes r the power m by n, and cos of theta plus iota sine of theta the power m by n, plus r the power m by n and cos of theta minus iota sine of theta the power m by n. Taking r the power m by n common, and now applying the De Moivre's theorem, this power is multiplied with the angle. So this is cos of m by n theta plus iota sine of m by n theta plus cos of m by n theta from here minus iota sine of m by n theta. So these two cancelled out, and we get r the power m by n into 2 cos of m by n theta. And now we need to put the value of r and theta over here. So what is r? It is square root of a square plus b square the power m by n. 2 cos of m by n into theta. What is the value for theta? It is tan inverse b by a. So this can be further written as a square plus b square the power m divided by 2n. Okay, I'm writing 2 over here, which is multiplied with this. Cos of m by n tan inverse b by a. So this is what is needed to be proved. Shown that this left hand side is equal to this right hand side. So we have shown that this left hand side is equal to this right hand side. Okay, thank you. Stay blessed.